Hello students. What we're covering right now in this extra example is what I mentioned at the end of example number 4. That is, what if I asked you, given some kind of borehole configuration, what is the effective stress at any depth? Say, how about 5.5 meters below surface? I just picked a number. Okay? It's below the first soil interface, but somewhere before the bottom of the borehole. Would you be able to calculate it? Let's try it together. I've shown here 5.5 meters in depth and sketched it throughout the calculations that we've already done for example number 4. So essentially, we basically have to repeat what we've done so far for the first 4 examples, but at this specific depth. Okay? All right. Now, another thing that I'm going to need for the purposes of this is to calculate what the distance is between this interface and 5.5 meters. Okay? That distance is 2.3 meters. Again, this is the distance from 3.2 meters and 5.5 meters. That is this distance here worth in the borehole. Okay. So again, refer to what you've sketched down for example 4. We were able to come up with this for the effective stress. So we have this value, this value. What is that value? I'm going to call that A. Well, as we've learned, the vertical stress here at A is the vertical stress above, 74.9 kilonewtons per square meter, plus, using the formula, the density of this material, 19.6 kilonewtons per cubic meters, times this depth, which is 2.3 meters, equals to 120.0 kilonewtons per square meter. So I'm just going to rewrite this over here. This here is 120.0 kilonewtons per square meter. That's what A is. Okay, let's calculate the pore water pressure at this same location. We'll call this point B. We're going to do it exactly the same way we've done it before. The pore water pressure here is equal to the pore water pressure above, 48.1, which is 48.1 kilonewtons per meter squared, plus the pore water pressure of this portion, which is 2.3 meters. So the density, based on the formula, is 9.81 kilonewtons per meter cubed times 2.3 meters equals to 70.7 kilonewtons per square meter. This here is 70.7. Now that we've gotten this far, can we calculate the effective stress at that same location, C? Well, the answer is yes, because this is the easy part, right? Once we have these two numbers, if we do this minus that, we can obtain the effective one. So C is equal to A minus B, which is equal to 120.0 minus 70.7 is equal to 49.3 kilonewtons per meter squared. So this is a bit of the long way of getting to the effective stress at any point in a distribution. But once you've mastered this, you can also figure out much shorter ways. There are many.